In this video, we're going to discuss Young diagrams. So suppose that we start with a partition. So let's say that we have a partition of the number 7. And that partition is, let's say, 1, 1, 2, and 3. If I write it in increasing order, we did that before. But for the sake of what we're going to do today, and again, both approaches are possible, let's write it in decreasing order. And let's create a diagram made up of boxes corresponding to each of the numbers. So the first number is 3, the largest. So we made a row of 2 boxes. Then we have a row, of 3 boxes. Then we have a row of 2 boxes corresponding to the number 2. And then we make a row with 1 box, and then finally one more row with 1 box. So this is called the Young diagram, and in particular, this will be a Young diagram of that corresponds to the partition lambda, or sometimes we might say of shape lambda. And we should note here that, again, there are places in the literature where these diagrams are done to have the largest number of boxes, the row with the largest number of boxes on the top, and then decrease on their way down, or vice versa. But it's certainly a monotonic order. And of course, we can look at it in a completely different way. So we can start with such a diagram. And as long as the number of boxes or squares goes down, we're going to call it a Young diagram. So for example, consider this one. This is a Young diagram. And if you wanted to specify what partition it corresponds to, that would be the partition consisting of the numbers 5, 3, 2, and 1. So this would correspond to a partition of the number 11. So this would correspond to a partition of 11. Now, a very interesting aspect of all this that we're going to consider is that such a diagram also gives rise to a certain path that starts from this point and the lower left corner and ends at the upper right corner. And I'm talking about this path here. So pretty much there is one-to-one correspondence between Young diagrams that start at this corner and that have 4 rows, if you like, and the top row has 5 elements, and paths that go from the lower left corner to the upper right corner, like this. We're going to look at this correspondence later, so for the moment being, what we would like to keep is the definition of a Young diagram, and that's all.